changing climate, and the potential for Mars to support life. To tell you why we were so excited, we have to go back a few months, when we were still a few miles away from Mount Sharp. At that point, our team started noticing distinct patterns in the rocks around us. There were tilted beds of sandstone, all facing south in the direction of Mount Sharp. The geologists in our team concluded that these tilted beds of sandstone formed where streams empty into standing bodies of water like lakes. The sediments carried by the flowing water sink when they enter the lake, forming a sloped wall that slowly advances forward as sediment continues to fall. In September of this year, Curiosity arrived at the rocks that form the base of Mount Sharp itself. What we found waiting for us was a new type of rock, one that forms when tiny particles of sediment slowly settle out within a lake, forming mud at the lake bottom. These mudstones are very finely layered, suggesting that the river and lake system was going through cycles of change. Our hypothesis is this: where now there is a mountain, there once was a lake. Over a span of perhaps millions of years, water flowed from the northern rim of Gale Crater towards the center, bringing sediment that slowly formed the lower layers of Mount Sharp. At any one time, the lake may only have been a few meters deep, just enough to form those sandstone deltas and thin layers of mud. But fluctuations in the water supply or the climate allowed this to happen over and over, slowly building up the mountain. Over the next few months, we'll continue to climb up the lower layers of Mount Sharp to see if our hypothesis for how it formed holds up. We'll also look at the chemistry of the rocks to see if the water that was once present would have been of the kind that could support microbial life if it ever was present. With only 30 vertical feet of the mountain behind us, we're sure there's a lot more to discover. I'm Ashwin Vasavada, and this has been your Curiosity Rover Report.